So apparently physics has trust issues now. Okay, so now you can't know where a particle is or how fast it's going. Sounds dumb, right? But no, that's literally what Heisenberg said. And he wasn't lying. Okay, so physics really hates us. So, welcome to the Heisenberg's Uncertainty Principle. That sounds simple, but makes the quantum world more confusing and awesome and interesting at the same time. Superposition. Okay, so basically, the universe looked at us and just said, "You can have either this, either that. You can't have both, brother." Okay, so let's get into it. So first of all, meet our little dude. It's an electron. Okay, it's an electron. So we want to know two things. First, where it is, so its position, or how fast it's going, so its momentum. Okay, simple, right? No, because in the quantum world things get weird. So suppose we have this particle, so our electron. Okay, he's a good dude. Well, to see it, to know its position, we have to have some light on it, don't we? We do. We have to see it. We need light to see it. But because it's an electron, we flash a light on it. I don't have a torch, but let's flash a light on it. Uh, so electrons are just tad bit bigger than photons. So those interaction with the photons, the light just makes we get to know its position. But those photons interacting with this electron we just hits it around and we have messed up how fast it's going again. Okay, there is a no win situation here, and that's kind of how you can say uncertainty works by particle. Okay, so it's a common misconception that people assume that is just because we have bad instruments, bad tools, but that's not really how it works. We Even if we had the best of the best equipment, see the best of the best instruments, it will not work. It's just how the world works. The rule still applies. It's not about tech, it's really how it works. In the quantum world, these particles have their own wave functions, bubbles of probability that collapses when we measure them. It's not about the equipment. Basically, when we when we have a particle, we know its location and we try to measure its momentum. Okay, the wave function for the location collapses and we don't know the location now, and vice versa for the momentum. If we know the momentum, measure the location, the wave function for the momentum collapses and we know the location but we don't know the momentum. Simple, right? Okay, so basically we know a particle's location, location, but we don't know its momentum. If we know its momentum, we don't know its location. That means it does not have a single exact position of momentum until we measure him. And when we try to measure one, we collapse that wave into something different, and the other property just goes fuzzy. We don't know nothing. And Heisenberg even gave a math version for that rule. Here it is. Okay. So this means the uncertainty of its position, how precise we know where the particle is, and then this it's, is the uncertainty of its momentum. We know how well we know its speed. Okay, and that h right over here. Okay, yeah, that h right over here is the Planck's constant. So basically, the smallest length, the universes do not cross sign. Okay, that's the smallest we can go, but But we ain't gonna go deep on this because my brain way too dumb for it. Okay, so let's just assume physics dropped this equation in the chat and then left it. Okay, so uh, so let's make it visual. Here we have the particle, and now we I have trapped it. We know approximate of its location. It's bouncing around in that cup. Okay. Uh, okay. I have no clue how fast it's headed, but as soon as I measure it, and I will let it roll freely. I know its speed now, but it could be anywhere possibly. As soon as I measure it, the wave function for the location collapses. We have this, and everything just goes weird. Okay. Okay. So this rule isn't just annoying. This actually shapes the universe. Okay. Because of this Heisenberg's uncertainty principle, electrons, the things that go around the nucleus of an atom, don't collapse into the nucleus and stays in the orbit. And because of it, atoms have structures and even vacuum energy exists. Vacuum energy meaning like in a complete vacuum where there is nothing, still quantum particles can pop out of nowhere. Out of nothing there is something. Okay, that is also one of the features of quantum mechanics. Okay, so some people also think that what if we cheat? Hmm? What if we got clever like and try to cheat the system like you probably did in school? Okay. What if I measure the position and you measure the momentum? Nice try, but it won't work because while I measure the location, you measure the momentum. You might think that we are measuring two different things. You should get the momentum, but and I should get the position. But no, because those both of those probabilities had the same wave function. And if you measure it, the wave function collapses. I measure it, the wave function collapses. So yeah, it's not gonna work. Universe said you can't cheat. Okay, and that's it. That's Heisenberg's uncertainty principle. You can measure how fast a particle is or where it is. You can't measure both. And that's uncertainty principle for you. I don't think there is any more to explain. So I will catch you in the next one.